get me in the video.
All the magnetite is stuck on the stir bar. Cool, yeah.
Can I go to the back?
Yeah.
What is that?
Ferrofluid, a magnetic liquid.
That's so cool.
I don't know how much it.
Everyone's video is just gonna have Zoe in the background. But
Our final solution contained two separate layers. Our bottom layer was the water layer, and the top layer was our kerosene layer. Some of you may have heard of the idea that like dissolves like, but the question is, what does that really mean? Well, an idea called polarity will answer that question. To first understand polarity, we must understand intermolecular forces. There are three main types of covalent attractive forces, which are hydrogen bonding, dipole-dipole attractions, and London dispersion forces. Starting from the least attractive of the forces, we have the London dispersion forces. Every compound contains London dispersion forces. London dispersion forces are present when two molecules are almost touching. And according to the kinetic molecular theory, electrons are always moving, so electrons will form temporary dipoles with each other to add London dispersion forces. Now let's talk about hydrogen bonding. Hydrogen forms very strong bonds to fluorine, oxygen, and nitrogen. And what do all these three elements have in common? They're the three most electronegative elements. So hydrogen bonds only form to these three separate elements. So finally, let's talk about dipole-dipole interactions. Take water, for example. The water molecule is not symmetrical, meaning you cannot draw a line down the middle without splitting the O in half. This means that to keep the water molecule together, the H and the O both have partial charges within each element. The H will take a partial positive charge, while the O will take a partial negative charge to help keep the molecule together. This will be defined as an arrow pointing either way with either a plus or a minus charge at the end. Now let's take a look at our reaction. As our reaction proceeded, all we were left with after adding the oleic acid was magnetite and water. As we saw in the video, we need to dissolve the magnetite, but not dissolve it in the water. There is a crucial difference between the water and the kerosene that we added, and who can guess it? The answer? Polarity. Water is polar and kerosene is a nonpolar organic solvent. All hydrocarbons are nonpolar, meaning all organic solvents are nonpolar as well. This means that the magnetite will become the magnetic liquid and the water will stay in its own separate layers. Because polar does not dissolve nonpolar, water will stay alone and kerosene will stay alone. So the reason why kerosene is on the top and water is on the bottom has to do with density. Because kerosene is less dense than water, kerosene will take the top and water will take the bottom.
Wake up in the morning feeling like P. Diddy.
Hey, what up, girl?
Grab my glasses, I'm out the door. I'm gonna hit this city.
Let's go.
Before I leave, brush my teeth with a bottle of Jack. Cause when I leave for the night, I ain't coming back. I'm talking pedicure on our toes, trying